Welcome everybody, and special welcome to ESRAD Dialectical thinkers who will now have kind of joined us because we've merged the special interest group from ESRAD into Centre for Applied Dialectical Thinking. So it's great to have a really broader group to attend. And a warm welcome to Danila Medvedev. Danila is a futurologist, a philosopher, a real thinker, and we're delighted that he's able to give us a talk today. It seems like barely a day goes past without another development in AI these days. We simply can't avoid it. And we're kind of seems like people are neatly divided into those that think AI is the greatest thing ever to happen to the human race, and those that think that AI is the worst thing that ever happened to the human race. But Danila is the one who's done a lot of thinking about this, and maybe he can integrate that dialectical position for us and take us perhaps into some space where we think about how our thinking as human beings can be, I guess, perhaps combined dialogically with the power of AI. I won't say any more than that for now. Danila, are you happy to make a start? And would you like us to ask questions during the presentation or after the presentation? What would work for you?
I would be happy to take questions during the presentation. You can use chat, or I have it on display, or interrupt if something is really outrageous or completely wrong, or maybe completely confusing. So feel free to do that. And then, of course, there will be time for questions afterwards if you're more comfortable with that. So I'm ready to start. And the topic of my presentation today is Beyond Dialectical Thinking, an integrated toolkit to upgrade human cognition and Outthink AI. AI is clearly a hook and an important and urgent development, but the idea to upgrade human cognition is a very old one indeed. 50 or 70 years ago, people started thinking about it as a practical challenge. And even though very few people are familiar with that, but Sam Altman, the head of OpenAI, before starting the AI company, he created a Human Advancement Research Center using partly his own money as part of Y Combinator research. It was created in 2015. So apparently he made a bet on human intelligence first, and only after all the invited experts failed utterly at producing something meaningful, he apparently decided that it's easier to automate human thinking anyway, so let's go with OpenAI. So there are a lot of very interesting threads, political, business, scientific, about this challenge. And of course, there is this philosophical issue, and also the civilizational issue. Like, we humans are sapient, we're Homo sapiens, so thinking apparently is important. And then the question is, of course, why no one is doing anything about upgrading human intelligence, and the investment in human intelligence is minuscule compared to investments in AI. So that's the political context. But I will be focusing more not on this big socio-economical context and political context. I will focus mostly on what I call an integrated toolkit to upgrade human cognition. And essentially, it's a framework or a theory or a set of methods and theories and mini theories that I think, when put together, explain relatively well how advanced thinking happens in humans. Not completely, of course, because I basically borrow a lot of ideas and frameworks from other researchers, but I think I managed to put it together to make it useful to understand what's actually happening in knowledge-intensive processes, in difficult cognitive processes, and how it can be managed and guided. So that's the main focus. And there will be, of course, complicated abstract ideas and very short references to obscure researchers, but I hope you are okay with that. Feel free to ask for clarification if needed. So that's the introduction about what is going to happen. And let me now start. So I'll begin with references to foundational theories, and it's not just a literature review. These are, I think, authors whose concepts and ideas must be understood and learned by anyone who wants to understand human thinking. So the first researcher, Bill Benson, still alive, together with his mentor, David Hayes, he studied cognitive evolution in our civilization. And he tried to understand what is different in how people created literature, music, how they thought, how they managed their societies. For example, in ancient Egypt, in ancient Greece, in Renaissance Italy, in modern United States. And he created, I think, the best model which explains the evolution of cognitive tools in human civilization. The second researcher is, of course, Elliot Jacks, the psychologist and management researcher, who came up with his model of human capability, of cognitive complexity, and he tried to explain adult development in humans in terms of their cognition. This is basically a continuation of pedagogy and child development research by Piaget and others. And Elliot Jacks picked this up essentially at 18 years when traditional pedagogy says development ceases and you are a ready-made human who lives without any change whatsoever. So Jacks and others like Keegan, for example, they explained what is happening in terms of cognitive complexity. And there are, of course, parallels to what is described in science of dialectical thinking, and methods such as cognitive interviews are also similar between what Jacks did and others. Key ideas that Jacks created, which formed the foundation of complex thinking, is orders of complexity and 4 types of cognitive processes. And these are relatively simple. So orders of complexity is the progression from concrete to abstract, which has many different stages. And researchers like Piaget explained how a child first understands an individual occurrence of an object like an apple, and then understands that the apple is the same even if it's moved and hidden. And then the person graduates to more abstract thinking, like first level abstractions, second level abstractions, and then like universal principles and models and so on. So, and this is done by a few other researchers on mental complexity, so it's not controversial. So also what Jacks added to this is 4 types of cognitive processes, where people basically can think, depending on their intellectual advancement, about an individual object, a set of objects, an object as a process being developed and changing, and a couple of processes being interconnected. What he found and explained is that these 4 types of cognitive processes, they develop sequentially and they develop at each order of complexity. So, and of course, one can say that there are some maybe practical nuances, and maybe it doesn't work 100% perfectly. But in my experience, I found that it explains quite well the level at which people can actually think in terms of being able to think about systems, about sets of systems, about interconnected systems, and the value of Jack's theories. He explains why this happens in such a way. So he called the differences between people cognitive strata, and he explained that different people follow different trajectories in their life. He called that modes. And this is key when we want to understand advanced thinking, because, I mean, Benson and Jacks, because apparently people are different, people are different at different stages in their life, and also our civilization is different. So we need to look at cognition as a developmental process for at civilizational level and at a personal level. And of course, you can extend that to also groups and organizations, but let's stick to people and civilization. The next author, key author, is George Mobus, former president of the International Society for System Sciences, and he developed a theory of sapiens, quite a good work, I think, where he explained, and I think it's the best explanation among all the different intelligence researchers of what intelligence actually consists of. The labels are not that important here, but the four components are emotions, the basic processes that happen in the limbic system, then creativity on the one hand and analytical intelligence on the other hand. One basically generates, another filters. And then at the top is the judgment or wisdom or true sapiens, which is basically accumulated experience, processed and transformed into advanced modes of thinking, such as dialectical thinking, systems thinking, and so on. And there are more details there, but he basically explains how we can think about intelligence and our abilities and ourselves as a complex, adaptive, evolving system. And I would add to that the autopoietic system, because what I'm going to talk about explains how systems or structures think about themselves. So that's number 3. And number 4 is, of course, Douglas Engelbart, the person who came up with the idea of augmenting human intelligence. And he also created the basically foundational framework for understanding intelligence and understanding how it can be extended using tools and methods. And I'll get to some of his ideas later. So that's the key thinkers, I think. So next, I want to simplify what I'm going to talk about. So let's say there are 3 components in this basic framing of what's going on and how we can develop our understanding of thinking. So first is the representation. This idea I will speak more about. It's basically the complex and multifaceted way we work with structure of concepts, structures of systems, and so on. It is related to symbolic representation, to semiotics, to models, to imagination, to schemas, etc., etc. But I'll speak more about that. The second thing is the relationships, which is related to one of the moments of dialectics and its links between concepts. So you can think about thought forms as obviously types of links between different concepts. And these 2 blocks, the representation is essentially a map of concepts, and relationships or thought forms, they explain what kind of connections are possible. And then we can go to metacognitive heuristics. You can call it any way you like, but it's essentially the processes that we have in our brain, in our mind, that create paths through this conceptual space. And I think many people who experimented with different cognitive practices, including taking various psychoactive substances and practicing various metacognitive skills, they understand that the flow of their thoughts can be controlled and can occur in different regimes, different modes. And of course, philosophically, this question was raised by as early as in 18th century by Hume, Hobbes, and others, who basically realized that humans think by association, and there are different types of associations between different concepts. And of course, it's not the only type of thinking. We have also visual processing and other types of processing. But my point is that for abstract thinking, this type of going from concept to concept and connecting several concepts together is the key. So these three components basically explain the abstract way how we can think about thinking. And one must mention here the recursion, this self-reflexivity, etc. When we create a way, and I'll say a bit more about that, for structures to describe structures, we can describe processes, we can describe the map of concepts, and then we can have this meta-cognition become more complicated. And I'll just say that those philosophers and mathematicians who try to understand how this works, some of them committed suicide, some of them went crazy, people like George Cantor, Gödel, Turing, and many others. And there are a number of interesting books and documentaries on that. One is Dangerous Knowledge by BBC, which explains that when you think too much about how you think, and when you create structures about structures in your brain, this tends to disrupt your sanity. So from this point, proceed with caution, I must warn you. But my belief is that it's possible to be careful here, just like with taking psychoactive drugs or going into totalitarian sects, though I wouldn't recommend that. But thinking about thinking is like very useful compared to other things. So final thing on this slide is that extending dialectics idea. The title of the talk is Beyond Dialectics, and there is a contribution that I think we can make is understanding that there is actually the fifth moment of dialectics, and that the 28 forms as they're described should not be grouped into 4, but should be grouped into 5 groups. And I'll explain that a little bit later. And if somebody wants, there is a text, long text, which is written by one of my colleagues, which describes why that makes perfect sense. But before I go to that, I want to give an illustration to better understand, better explain what representation is. Another word I have is like a formal image, but there's no good word for that. And we shouldn't really strive for perfect definitions. We should strive to understand the structure of the concept. So what we have here is a structured description with elements of the system which are explicitly highlighted. That means that we externalize our thinking, we make it explicit, we create borders between concepts, and creating borders between concepts is one of the fundamental mental skill that we have. So thinking about what we have in our head in terms of this structured diagram is actually very useful. If we have a strictly defined format, it doesn't have to be strict in how we apply it, but it should be understood by other people. Then we can exchange our ideas. We can share our ideas without a text or oral description. We can just give the structure. And with very limited training, people can understand how it works. And of course, we have many different examples where visual language was successfully used in programming, in engineering, in various types of sciences, etc. And there was this presentation by Robert Horn, who did a lot of very good work describing what we have in terms of visual language. But I think we can go one step further, or maybe half a step further, and understand that this actually leads us to a new type of thinking, or a type of thinking which was crystallizing since the middle of the 20th century, a structured, complex, advanced thinking. And I think it should rely on these externalized tools, externalized representations, not just on text or voice. And the illustration that is here, as you probably read already, there is a bit of text at the bottom left from an official document, which speaks in a traditional, very complicated bureaucratic way about relation between different types of documents, concepts, methodologies, etc. And the right part shows how you can create a diagram which shows what goes where, like what kind of actors you have, what kind of processes you have, what kind of representations you have, and you can have connections between different parts. So essentially you have this visual, virtual representation of an abstract concept or a set of concepts. And this is a different way of thinking, different way of processing the structures. So that's an example of representation. And of course, it doesn't have to be in a single format. You can use many different ones from different visual languages. And hopefully this will evolve and people will be better able to learn it and to apply it. Now about extending the 28 or restructuring the 28 thought forms and extending the moments of dialectics. What you see here is, I think, a very simple diagram of 28 thought forms. When I was studying with Otto Lasker, I immediately noticed how difficult it actually is for people to comprehend what those thought forms are and how difficult it is to teach them. Basically, the only method is just go and reread the document again and then practice and then reread again. And I thought, is it possible to just explain this all in one simple picture? And this is one of the final attempts. So what we see here is first, each thought form is represented by an emoji and a number, which corresponds to the 28 thought forms in Basech's and Lasker's documents. And you also have two empty blocks on the left and on the right, which represent essentially our target system as it was and as it will be. And you can see here how you can visually structure what is actually like occurring from different points of view. In the middle, you have this square 4x4, which represents the target system with its potential development on the right side, with vertical pair, subsystem and supersystem 9 and 8 on the left, and with basically a dynamic interaction on the bottom, 4 and 20. And then you have on the left how the system emerges from different processes, 1, 2, and 3, how connections emerge, and then you go to the system itself, the center part of our understanding of the life cycle of the system. On the right, you have ways to go basically through the transformation. And then what I did, what I found necessary to do is to actually move 4 thought forms, 13, 5, 18, and 28, to a different section, because they basically speak about evolution of our understanding. So you have different basically representations of like this context, and then you have the process of development of our understanding, number 5, and then you have different basically ideas and value systems, number 18. And then you have this evaluation thought form 25, which leads also to 28, which is the total synthesis. And it seemed to me that the top 4 thought forms, and also maybe 25 and can be combined into the representation moment of dialectics, which basically dialectically explains the opposition of an object and whoever thinks about it and what tools or representations they use to think about it. So there is a long document which puts this in a more formal way, but this, I think, is the place which working with representations occupies in complex dialectical thinking. That was the connection with the dialectical thinking. But what I found missing from most of the models and theories about intelligence and thinking is the foundational level, basically something which is not laboratory style cognitive science, which is about basic perception and cognition, but something above that, but below domain specific thinking. So I wanted to explore this fundamental thinking skills or methods. And here are some key concepts which put this together into the perspective. So first is the cognitive ranks by Bill Benson and symbolic manipulation evolution by Douglas Engelbart, who basically found that we went as a civilization from oral language to text to structured text and algorithms and calculations, and then eventually to more complex multidimensional thinking and computation, which also has this potential for self-reflectivity. Then there are 5 types of structures from Engelbart's conceptual framework, which are mental structures, structures we have in our brain, then the conceptual structures that we have in our collective understanding, like philosophy and science of thinking, etc. Then symbolic structures, basically any way we can write or draw something or record or say something, and then 2 more structures. Process structures is anything that happens over time, like how we think, how we write something, anything that is temporal, and also the physical structures, which link this back to the physical reality, including our brain and computer and paper and pencils, etc. And what is really amazing about these 5 types of structures, and it's strange that nobody really picked this up, despite this being a 1962 document, is that these structures give us a complete tool set, a complete toolbox to basically think or say something about other structures. So we can have a symbolic structure which describes a process structure for changing the conceptual structure, and in all the other different combinations. If you really want to go crazy, you can try to think about this as a tetrahedra with something in the center, and then you can play with it. But it's basically a graph of 5 objects which are interconnected in certain ways. And this really basically makes something extremely complex and powerful relatively simple to understand. So I think this is the key. And symbolic manipulation is Engelbart's idea that our ability to manipulate structures also evolved, like with the cognitive ranks. So initially, we could only manipulate structures very poorly in our head. Then we could say something aloud, then write it. But in the beginning, in the middle of 20th century, with the beginning of computer revolution, which Engelbart initiated, the idea was that we would use computers to manipulate structures, including conceptual structures. That was the whole point of creating personal computer. The mouse, the keyboard, the hyperlinks, etc. It was all so that engineers and managers and scientists and philosophers could manipulate on a computer screen concepts and create other concepts, structures, basically. So that leads us to a very interesting potential definition of what thinking is in this framework. Thinking is basically processing structures or transferring structures. When you take a symbolic structure and you look at it, you create a mental structure in your head. And then you can create a conceptual structure if you communicate with others. And these structures can be different. It can be like a schema, it can be a template, a model, an abstract model, it can be a mind virus, something which replicates like a complex of memes, it can be different things, but these are all structured. And as a side note, I want to mention that only 2 years ago, there was an article where system thinking scientists for the first time clarified what is actually the structure of a system. So I just want to comment here that our civilizational and scientific ability to understand how we think about systems, for instance, is not that developed. So nobody could write with clarity what the structure of a system is, and people had different ideas, like it's logical, functional structures, and there was a lot of confusion. So some people finally 2 years ago wrote an article where they just put all this together and synthesized and explained that the best way to think about structure of a system is this. So that is, of course, related to high-level thinking. It's not about what we do when we dance, when we go to nature, but that's what we do as philosophers, thinkers, managers, strategists, etc., etc. 3 more key concepts about thinking. The 4 mechanisms of thought and attention control is basically how we can create paths through this conceptual space. And I think it's really funny because we are all familiar with mechanisms number 1 and 2. These are system 1 and system 2 written about by Kahneman. What is really funny is that in the famous book, in the introduction, Kahneman describes how he and Tversky collaborated. And it was clear from the introduction that they didn't use system 1 or system 2. What they actually used was something that one blogger on Medium called system 3, which is thinking structured using language, using dialogue. When you have 2 people talking, they're not engaging their system 1, their automatic quick reaction. They're not engaging consciously controlled autonomous system 2. They are actually playing according to the rules of language. I ask you a question. Do you understand me? And you think in your head about the reply. Maybe you don't reply aloud, but you think about the reply. When I say first, second, and third, you have a structure of 3 elements. So in this way, language creates structure for our thinking. And here is an obvious connection to one of the ideas from the title, the artificial intelligence. I think it's very clear that what language models and chatbots based on language models use is almost entirely this third mechanism of thought control. Basically, what happens during runtime when you ask a question, when you write a prompt, and then the system writes text back, is essentially the rules of language defining how the thought occurs. And some simple thinking can occur this way. Like when you say, on the one hand, on the other hand, or when you say, I want to look at this, like, what would Jesus do? Or like, let's look at this from a political point of view, etc. So here you control your thinking through language. And the 4th mechanism of thought and attention control, I was thinking, okay, number 3 is obviously important, and it exists. You can use it alone, you can use it in dialogue, in polylogue, but what next? And after some thinking, I came up with the idea that mechanism number 4 is the basically significant attention control when you have willpower to focus your attention somewhere, and where you use an exocortex, where you use an external representation of your thoughts. Because what happens then is that in this physical space where you have this computer with a complex diagram or paper or maybe many post-it notes, what you can do is you can direct your attention using very limited amount of resources, because it's very simple. You are focusing your attention on a physical object, and then you can read what is written on that piece of paper. And then you can think or do something or communicate according to what is written there, using associations, using algorithms, etc., using dialectical thinking. And when we have this external representation of our basically thought space, we can go towards this 4th mechanism of thought, which can also be collective, because we can have a common visual representation of thinking. And if we don't fall back to our familiar oral discussion, when we don't look people in the eye and try to talk it through, when instead we manipulate objects in the shared reality, we can actually do some very complicated thinking with very high accuracy. And this is type of thinking which an LLM, for example, cannot do. This is something a computer can do using traditional artificial intelligence, like traditional logical algorithms, etc., heuristics, and so on. But this is something which people do not really understand is possible and do not really do, except in a very, very, very limited way. So that's the four mechanism of thought. The concept called HLAMT, or H-L-A-M-T, is from Engelbart's framework. He basically said that when we augment human intelligence, we have human with his basic cognitive capabilities, which I'll talk about next. And then we have the augmentation subsystem, which includes language, artifacts, and methods. And of course, we need training, hence the T, to teach people a new language, new artifacts like computers, and new methods. And artifacts are basically paper, pencil, different types of index cards, and so on, and computers. And methods are everything that we can use, from trees to dialectical thinking, critical thinking, rational thinking, and so on. And the language is really also like a missing link, because all the linguists and all the specialists in semiotics, they don't care about complex types of languages. What they care about are basically two things: how to write a sentence and how language came up to be. And unfortunately, they're not interested in how a book is structured or how a collection of articles is structured. They're not interested in what's the structure of a text, a topological, geometrical structure of meaning. The people who study language don't care about that. Also, they don't want to call a diagram a visual language. They want to say, okay, no, that's not language. Language is what children learn autonomously, and so on. But when we extend what we mean by language, we can also understand that any type of structure, if we can have essentially syntax and objects and ontologies, it's a language. And we can teach people new languages. And one of the most, I think, obvious next steps and a powerful new tool is to teach them and us to use structured language with visual representation. Basically creating diagrams on the fly of the abstract ideas that we have and sharing them with other people and developing them. So that's the augmentation part. And the final block here, the human evolution and working memory capacity limits, is also a very fun one. You are all familiar, of course, with the concept of working memory, and also the magic number, so-called the 7 ± 2, which was later shown to be less than 7, like 5 or maybe 4 with some people. And we also have quite a good explanation of why working memory capacity is the key determinant of human intelligence, because that's the main difference we have with animals, with the higher apes. And there are also a lot of additional research on how good strategy, advanced breakthrough technologies and scientific advances and other things are created by people who are able to extend their working memory capacity using some way or another. So that's the key concept. And another way it's key is that when we think about how working memory capacity is used when people think abstractly about something unusual. It's very simple. We need one unit of storage per object or concept. But unfortunately, if we're using complex thinking, like dialectical thinking, we also need one unit per connection. And sometimes we need to have several dimensions, like we need to use several thought forms to think about a particular object, which means that if we have 2 or 3 elements and several ways we want to look at them, we quickly exhaust our working memory capacity. And that's why it's impossible for any of you to explain to an inexperienced person anything about dialectics. So, of course, when you put this into long-term memory, it becomes easier, because long-term memory is essentially unlimited, and you can very quickly bring something from it using associative memory. So it's very simple. Recall is quick, capacity is unlimited. But when people need to think about something new, that's where they break down. And it's impossible to explain something like what I'm talking to you about today to a person without like significantly overloading their cognitive resources. Because to be able to track all these abstract concepts and references, that's difficult even for people who are familiar with these topics. But if they're not familiar, they just melt and their brain explodes. I've seen that many times. But I think it's possible if we improve the structuring, if we use visual tools, if we use different hacks, it becomes possible to explain to people what thinking is, how civilization thinks, how our scientific community creates knowledge and thinks about it. And then we have, of course, the revolution. So this is a summary slide which shows together some of the components. I've described all that already. And then I'll just touch on a few more important concepts without going into many details. So first is the exocortex. We, of course, have the cortex and the neocortex, which are inside our brain. And people came up with the idea that, like you can have an exoskeleton, you can also have an exocortex. That is part of your cortex, which is outside your skull, basically in a computer. So if you can move some of the thinking into the software, mind mapping, diagramming, note taking, etc., it becomes your exocortex, provided you know how to use it well, provided the interface between you and the computer program works, and then you extend your intelligence significantly. I've been working for about 10 years on one implementation of an exocortex called neurocode, and there are many links which I will not follow now to the media theory, like how text, how computers evolved, hypertext, etc., who did what, why, etc., what didn't work, and the connection to visual language, like what Robert Horn studied, and the knowledge itself, like how knowledge was maintained by our civilization for the past several thousand years, how people copied books by hand, how they traveled from Baghdad to Cordoba, how they like asked emperors for a copy of textbook on geometry, and so on. And then how Gutenberg created the printing press, and then some other stuff happened, and then more stuff happened. And there are a couple of historical books which explain this all very clearly, very well. This was basically a multi-millennia quest to organize human knowledge, which is intimately connected to intelligence. Because basically what intelligence does, according to this framework, is creates new structures, and structures are essentially knowledge. If they're not about like data or information, they're more abstract, they're creating knowledge. And then there was this quest, how we can organize the knowledge that we have about the world. From Kabbalah to encyclopedias, people really strived and struggled to do that. And of course, this all led us today to 2025, when we can move all the human knowledge, all the written knowledge, into a vector database where it's in a multidimensional space. And then you can train a neural network so that it can draw different elements and connect them in different ways. And it's basically the culmination of all those encyclopedias, Encyclopedia Britannica, Internet, Wikipedia, and so on. So the question becomes, as a civilization that has this cognitive capacity, what do we want from thinking tools, from knowledge management tools, and who is making those decisions? And can we actually affect them so that in the next couple of decades, something good happens and not something bad? And that's a whole different interesting section. But going forward, one solution I have is that we need to go back to the ideas of Engelbart, but on a completely new level. And basically, what I'm trying to create is an software platform for high-level functions. You can call them high-level business functions if you are selling this to companies. You can call it governance functions if you're selling to government, or you can call it cognitive or creative or knowledge functions if you're selling it to academia, for example. But essentially, it's about creating software tools which support this fourth cognitive rank, fourth mechanism of thinking, basically processes where you can create complex models, these representations, and you can share them with others, and not use like PDF or text or something like that. And also not to offload this to chatbots and LLMs. Basically, we need software which allows people to create strategies, system models, interconnected, multi-domain, multi-theory models of integrated problems, hyperobjects, etc. And that's, I think, the leverage point for intelligence augmentation, for making humans think better. an interesting game theoretic and like risk-related aspect here is what will happen with AI. And my main conclusion that I came to about the current state of AI is that, fortunately, the lead developers and the founders and owners and directors of the major AI companies do not have a good model of thinking. The main reason is probably that they are mostly engineers and they do not treat humanities with respect. They don't care about psychology because they are mostly psychopaths and sociopaths. So what good can psychology tell them? So they don't understand what actually happens. They don't understand anything about this third mechanism, fourth mechanism, different structures, different processes going on in our society, in our brain, which is why they're creating this fake non-working intelligence, which still can do a lot of interesting tricks because it partly works, but nobody understands why it works, and nobody has a plan or very few people have some adequate plans how to develop. But at the same time, it's rather obvious that in about 20 to 30 years, it's essentially guaranteed that some smart person will be able to implement the thinking capability in a computer, which can do this complex thinking. And that would mean that for a fraction of compute, like thousands of times less than current LLM models use, they would create a superhuman intelligence, not the fake one being sold today, but the real one. But still, we have some time, maybe up to 20 years, to actually deal with the situation. And what I propose is that we need to work on human intelligence and human superintelligence. I will also mention that like there are more models which there are no QR code or link here, but for those who want to go deeper, there is some more stuff, and some of that is untranslated, so it's in Russian. But basically, it's possible to create a lot of understanding of these related domains and put them together in a way which is relatively easy to follow. So that's this is the summary of what we covered today. So a very simple diagram. I'll go very briefly over it. So we have we started with the thought forms, and then I introduced what representations are, and then this basically connected to of the framework for augmented intelligence using stuff that Engelbart created, but also others. And this means we can teach thinking, that's teaching the methods and the artifacts and the language. And this would improve our cognitive capabilities and lead to many interesting applications. And at the bottom, we have how it works. So the basic human capabilities and the integrated understanding that I've tried to create, and then various implications of that. And the call to action goes through some things related to tools, artifacts, so like creating this ID platform using some of the like results that we already created, and then making this a political issue. And of course, there was one case when intelligence was made into a political issue. That was what Luis Alberto Machado did in Venezuela, when he argued for the right to be intelligent and managed to create a ministry for intellectual development. So the first and the only time in the world when that happened. It didn't last long, but for 5 years that thing existed. So I think we can actually do a second attempt, which this time may work much better. And also some additional consequences, just to mention them. So innovation requires us to model technical systems. Very few people actually do good research on what technology is, people like Brian Arthur or Jeffrey Funk. When people want to create complex innovations, they need complex thinking for that. The same is true in strategy. The leading thinker about strategic management, Roger Martin, explained quite well how top strategists, like best CEOs, how they work in cognitive terms, how they actually model the salient features of the environment and the system they manage, and how they're different from normal people in this regard. So the same thing was done in futurology when Australian futurologist Dennis Least created this method called scenario network mapping, which is also about how to create a visual tool for people to share models of explicitly connected elements using a certain process, like a 4-day workshop, where they can create a very complex and very detailed understanding of the future. And these are examples from these high-level areas, innovation strategy and futurology. There are also social implications. One of the challenges that we have today is, of course, the challenge of postmodernism. Maybe it's worse than racism and ecological devastation combined, because postmodernism means that nobody actually understands anything and nobody cares, and my opinion is as good or as bad as anybody else. And I think that this postmodernism can be explained quite well through the lens of our limited cognitive capabilities as persons and as society. And if we improve that, maybe we can build back the links that are required for systemic thinking. There is like a little bit more detail about that, and that's one of the interesting applications here. And this can be used for things like social architecture. One of the projects I'm working on in Russia is related to that, how we can understand society, how we can describe it, and then create forecasts and strategies. And also, of course, the long overdue solving global problems, because one of the reasons why Engelbart wanted to create intelligence augmentation and computers was actually to give us collective capability to solve global problems back in 1950s. Today, it's as urgent as ever, and intelligence is needed. And what this leads us to is we can for the first time in history, we can think realistically about creating superintelligence from us, from humans, from individual humans, like any one of us, from groups, from complicated groups and differently structured groups, from societies, and so on. And this, I think, is a very important area of work, and of course, thinking and research and action and so on. And I think when we want to frame this politically, one of the modern frameworks here is no-Marxism, which, if modified a little bit, would say basically that cognitive elite, people who are able to think about complicated stuff and who are also like capable and resourceful and have some connections and some experience, they can actually understand their interests, their common interests, and they can understand that the system that exists doesn't serve their interests. And the interest is basically make the world a better place, solve global problems, and so on. And these people can become what in Marxism is called a revolutionary class. A group of people with common interests who understand that they need to change the social order and through certain processes can actually achieve that change. And some people confuse this cognitive elite with groups like cognitariat, or maybe programmers, or maybe tech billionaires. And I think it's incorrect view. I think what is important is actually the quality of thinking. If a person is able to think systemically, strategically, dialectically, and so on, then that person sees the world extremely differently. And that person may actually be able to connect with others who see the world the same way, because they're interested in playing positive sum games and have this ability to be altruistic and to think objectively about some tasks. And that is, I think, a very good political solution, how we can quickly fix all the mess that we have. Maybe not very quickly, but we can do that. So that's the journey from the introductory premises, like what we understand about thinking, how we can extend dialectical thinking, and what kind of mechanisms and tools we can use here, including how to create structures that describe this and how we can use these structures to help us with other structures. And that concludes the presentation.
Thank you, Danila. Well, you've given us a lot there to think about. I notice in the chat there is one question from Rebecca, so we might go straight to that. It would be helpful also if you could say a little bit more about NeuroCod, exactly what it is and how do you use it. I'm assuming that NeuroCod is partly responsible for putting your presentation together, but I could be wrong about that. But let me just read out Rebecca's question first, and then perhaps we could get on to Neurocod in a moment or two. So Rebecca writes, Danila, looking back on the 4 mechanisms of thinking, I was wondering where you would place embodied knowledge. Think of playing an instrument, touch typing, dance, or painting. I tried a few years ago to have performers in the arts explain to me, in Method 3 language, how they see, feel, know that complex thinking underlies a performance.
I think the embodied knowledge and embodied intelligence, it shouldn't be considered a separate part from the mechanisms, because there is also the use of these mechanisms to actually do something. Like when you rehearse something, when you rehearse a particular move, you do that autonomously, automatically. You do that automatically. That means the system first reacts and works. Basically, you start moving and then you remember the move. Another way is when you have this conscious control, especially when you train, that's the system 2. So you know what you need to do, you focus your attention, you do that. And then depending on what is being done, the third mechanism is rarely applied. But when you think about what, for example, a music conductor, orchestra conductor would do, he would direct others using this simple language of gestures and maybe moving the body or moving the hands. And that is essentially this language coordination, but very simple, because there are not many words that he can say. He can say, like, I mean, I've watched some videos on what conductors do, but I haven't done that myself, so I wouldn't describe what exactly is being done there. And then you can have like some experimental examples of mechanism 4, when you have like this digital artist who has like this digital turntables and then creates, like, synthesizes music and so on. So that can be third, a little bit of like moving towards this fourth mechanism. But it's really not about being dogmatic here. It's one lens through which we can understand this control mechanisms and control processes. And that's the answer to the embedded knowledge and embedded intelligence question. Leadership. So what I want to say is that I had some success talking to the people in the different industries about this integrated problem. Like, they need to do strategy and they can't do strategy because they can't think. Their teams can think. They don't have the tools. And we have a couple of projects that we started implementing both the artifact, the neurocode, the language, this basic level, and the methods in companies such as, for example, Rosatom Renewable Energy, which is the renewable energy division of Rosatom Atomic Energy Corporation, at the level of director of strategy and the general director. And there are other examples where people can understand that the problems that they have require not just a simple, like, training session or some coaching, but they actually require this reinvention based on the theories of adult development and understanding what capable people who are adults do differently from people who are just teenagers or young professionals.
Would you like to say a little bit about how we can help people develop their thinking? A lot of people have problems with basic reasoning, mathematical reasoning, for example, and not everyone can get their minds around dialectical thinking, appreciation of the synthesis of opposites, dealing with contradictions, going beyond and/or thinking. How can we help people, firstly, develop their ability in these areas, and then go on to what you're talking about here in terms of superintelligence?
Well, I think there are distinct groups that we can target, and I will talk about 2 of them. One possibility is actually going to young children of course, you would probably want to focus on gifted children first, at least initially. Like children between 6 and 10 years old should be able to understand things like basic graph theory, for example. Graph theory is not being taught in regular mathematics courses, even though it's very simple. Like you have dots, you have lines between them, and there are some like rules, and you know some things about these graphs, and you can play with it. So it's not really that complicated. I wouldn't say it's more complicated than geometry. I would say it's about the same. And geometry is being taught to children without a problem. I mean, maybe not very successfully, but nobody died from that. So I think it's possible to teach without any like deep research or advanced design work. It's possible to just take children, like groups 10, 30 in different classes, different schools, etc., and basically give them this additional training course on thinking, on abstract thinking. Initially, they would not be able to think very well into using the dialectical thinking and more advanced thinking, but they would be able to understand things like when you are thinking about an object or a system, first it emerged somehow, and it could emerge through different mechanisms, and that's thought forms 1, 2, and 3, and you can look it up with some nice pictures and so on. And then like you can have a system, and the system has development potential. So these words can be understood by children, and I think that's where we should, well, somebody should experiment, because that could actually work quite well. Basically, it should be a skill just like writing, reading, or arithmetic, or count mathematics, or music maybe, so it should be doable. And the second group is the top leaders, like people who are ethically like somewhat okay. So you shouldn't want to like teach this to evil people, but people who honestly want to do something good just can't really manage to do that because it's so complex and difficult. And this is where I think like those who understand thinking, those who work with thinking methods and theory and tools, etc., need to like first differentiate a little bit, because some people pretend that they understand it, like many coaches, consultants who just sell strategy sessions or who just sell workshops on creative thinking or design thinking. Many of them, they do not understand anything. Some of the people actually work very deeply on this, and they have like decades of experience and they understand how it works. Others just copy the names. So if we can take the people who are honest about this, and if we can be critical where needed, then we can have this core group, which would hopefully have some weight and some authorities and intellectual authority, and be able to talk through different connections, because people who are doing that or have their personal network talk to people like a minister of economic development here, a minister of science there, a head of a UN development agency there, and basically tell them that, okay, there's this toolbox, you can do this, and you should try improving the strategy, futurology, innovation, problem solving, and so on, and not just do symbolic workshops or create presentations. So that, I think, and this is basically like, even though it can be called a revolutionary like work, because you would be overthrowing existing order, but it wouldn't look like it on the surface. It would look like an expert community with people with some free time and the ability to understand the social economic systems. They decide, okay, we should like package this and push this to this guy, to this guy, to this guy, and then see how it works. And as an example of who could be interested in that, I would use an example from China. There is a guy called Wang Hunin, who was and is the chief ideologist under the three latest heads of China. Even though usually when the leader changes, there's like not necessarily a purge, but the top elite is actually retired and replaced. But in this case, there's a guy who understands culture and economics and ideology and Chinese strategy so well that he's basically irreplaceable, and he's always somewhere in the background in the photos where Xi Jinping is like in the foreground. So like the guy like Wang Hunin would definitely understand the value of something like this. And then it becomes the question of like negotiation and like who to talk to and what to offer and what's the balance of interests. Because Becken said famously that knowledge itself is power. We can understand today that intelligence can also be a power if wielded well. But like how this game will be played in the next couple of decades, that's an open question. But if we don't play it, then we by definition lose. Good question. Thank you. I am of the opinion that in terms of like actual processing, there cannot be a free lunch. There's no such thing as a free lunch. So your subconscious probably did this work. And also when you actually read those 10 books, you actually thought in the background, maybe not consciously, about the problem. And then you had different parts which you were not aware of, but then they fell into a solution, into a single final solution. And what we know is that people like Mendeleev, for example, like they didn't just dream up the periodic table. They actually, like Mendeleev himself, he worked on a huge variety of topics: chemistry, physics, geography, economics, futurology, demographics, etc. So like he was doing a lot of this intellectual work, but you can definitely do that unconsciously, and that is connected to like different psychological practices where many people experiment with things like lucid dreaming and so on. So maybe you can, and I know some people claim that they can ask themselves a question and then basically think about it in the background without being consciously aware of it. But I think in terms of working with intuition, there are basically two types of intuitions. One is the natural physical intuition that children have, something which is hardwired in our genes, in our brains. And then there is the second type of intuition, which George Mobus writes about when he talks about this judgment, this wisdom, because this intuition is created by experience. You have so many different templates and patterns that when you have a complex problem, you might be able to find it much quicker than others without necessarily doing all the work consciously. I'm personally not that skilled here, but I know some people who claim to be able to do quite a lot. And when you read some documents on how, for example, fighter pilots, space astronauts, and special forces are trained, there is definitely a lot of psychology involved there, people being able to control their state. And one of the recent books I was reading, The Art of Clear Thinking, told how emotion control was instituted in all the Air Force training in the United States, so that you no longer had this basically elimination of people who can't control their emotion, but instead you had training and skills and actual processes for that. So I think we will be able to do that. And also when you think about 10 years in the future, 20 years in the future, there is a lot of stuff you can do with drugs, with neural implants, but it's not magic. We need to go on this path, and eventually we will be able to access some of what is happening. And I'm personally content with doing most of my thinking consciously right now, but I know that like people have sub-personalities and different processes on different work on different scale. So that's part of cognition as well, just not the one that I control very well or I'm very familiar with.
Yeah.
Thanks for the question. Several questions here. I'll answer the easier one first. About going to the library. I think any person who wants to be capable, intelligent, well-developed adult, much higher than average, would of course need to use ancient tools as well, like printed books, using voice, using conversation in a debate, on a podium, in a theater, and so on. People should be able to see. People should be able to like command others to do something, like in the Dune movies and books, using their voice. And people would also may need to like write hieroglyphics, because that's also cognitively empowering and interesting, and maybe even create cuneiform on clay tables. All that actually develops our cognition and gives us better skills, like learning a new language. However, when you're talking about an average person, they would probably not be interested that much about that. Like people don't write sheet music, mostly they don't write hieroglyphics. Even some people in China forget how to write them. So some people would want to use the simplest solution, but we need to look at different groups differently. Adults who went through this development and experience and who are much more capable, they need one type of tools, and they would get one type of benefit. The mass audience needs different tools, and I'm not making a judgment here like what kind of tools. And of course, it's an ethical and political and cultural issue, but it's distinct from what we should do to the top thinkers. And the second part of your question is about how new things are created. And here, well, we have some research, very good research done over the 20th century, which showed how inventors operate, like what Heinrich Altschuler did when he developed the TRIZ theory of inventive problem solving. And also a very common view, not fully correct, but the simple one, is the model, the combinatorial model of innovation, which says that you basically combine different ideas and then you get innovation. In reality, you need to combine not random ideas, but you need to combine better ideas in the right way, in the right sequence. Like it's more advanced combinatorial innovation. And that's exactly where tools like I described can help. Because when you need to think about a problem which has like 20 different dimensions, even before you create an explicit computer model or a physical model, you need to think abstractly about this. And people like Nikola Tesla could reportedly do that in their head and could simulate a machine and tell whether it would work or not. Others don't have this capability, so we need to create this capability for them. And also, one thing I want to mention is that different people have very different thinking processes. Sometimes I ask people question, how do you think? And listen to their description. And I've met one person, she was actually thinking visually, using actual paintings in the frames in her imagination. So she wasn't just moving blocks on a diagram, she was moving actual paintings when thinking about stuff. And other people say that when they attend a meeting, they have a recording of the meeting, which they can go over and they can play it back and forth. So like there are many different cognitive processes. And of course, what I described could look as a certain homogenization, but I'm not definitely not saying that everybody should think the same way. What I'm saying is that there seem to be basic foundational processes, and it would be good if we could enhance everybody's ability to do that. If people can think in different ways, so much better.
Danila, couldn't we just teach AI to do all of these things? Wouldn't that be easier than trying to teach humans?
Well, that's there's an ethical part. There is the risk management part, and then the practical part. And I think the ethical part is that we absolutely shouldn't do that, because there's no such entity as AI. if there was a robot from, I don't know, from our laboratories like Terminator with Arnold Schwarzenegger, who would be a person, who would be an entity with certain preferences, then we could talk to that entity and ask that entity, like, would you be willing to take over economic planning and political management and diplomacy and so on? And that entity would say, like, yeah, I could do that. And if we trust it, okay, utopia. But in reality, there is no entity. AI is a technology which is controlled by absolute crazy, like psychopaths. Some of them, like the former one of the top managers of Yahoo, actually killed his mother after talking to a chatbot. Another one of the top investors in OpenAI went crazy on Twitter saying that he's doing vibe physics and inventing new theories of the universe. And that's the person who invented $200 million into OpenAI. And I presume that most likely Sam Altman and people like Eric Schmidt and others, Satya Nadella, they are constantly talking to these language models through chatbots, and they're talking to them about essentially world domination. There's no question about that. They're definitely asking, how can we crush the competition? And they're creating this loop, which is self-reinforcing, where it's not AI doing something. It's the subconscious of a psychopath doing something. And they are controlling AI. They're controlling the decisions and the products and the platforms. And if we say we should teach AI to do that, that sounds like a very, very, very dangerous and bad choice. It's not the same because social control is a well understood technocratic totalitarian technology from like 1930s, 1920s. And China can do that. The United States can do that. Russia can do that. And different countries do it in different style. But essentially, in every country, you have a person responsible for like keeping people under control. And sometimes they use AI, especially the simple tools, like tools for text mining, tools for pattern recognition, matching faces, and so on. So they definitely do that. But what Nick was asking, I think, is that there could be the AI, and we would give it the capability to do actual high-level thinking. And that, I think, is very different from what China is doing, because China, I think, is no different in terms of how much awareness and understanding they have of what intelligence is. So they're basically doing the same stuff. Like DeepSeek was basically open source adaptation, improved, optimized, but not something that they created from first principles.
Thank you. Well, it's gone past just a moment or two ago. I don't know if there are any other questions. If not, then I think we might wind up. Danila, it would be really good to know how people could contact you who'd like to know more.
Yep. So
if you could put that in the chat, that would be.
Yep. I'll do that.
Wonderful. And is there anything that you would like from this group by way of support, feedback, or anything?
Definitely. Well, the main like different, because like obviously people who came here and who sat through my talk, they obviously are intelligent and obviously understand quite a lot about thinking. So that's like a common trait. But the difference, I think, the differentiation factor is the what's called the agency and how like big this horizon of control is, how big is the will to power, and like all these psychological constructs. Because like this is essentially about this it can be revolutionary change, it can be evolutionary, but it's more revolutionary because time is definitely short in terms of how we will manage knowledge and society with the digital this ecosystem. So like if you are interested to like really shake things up in a good way, and maybe not just shake but construct them, like I would very much like to basically start that work and common discussion and modeling and strategizing and thinking like who could be involved here and there, because like I've been looking for like at the world who are the trying to find who are the live players using the terminology of Samaburia, and obviously there are a number of people, and I know that some of the people like are not good enough to actually work at this level of complexity, but definitely there are thousands of people, maybe even tens of thousands of people who can actually contribute to the social change. And the obvious action and step is like committing to that and saying like I want to do this and that, I can help with that, I know some people are also capable, and then doing this next step in cognition, which I think is the key, because anyone can talk about that about this on a podcast like Joe Rogan's or some other, and there are very smart people who can talk for 2 hours about AI, about intelligence, about like human development. But I think what is important is that we recognize that since this is really a hyper object and we are limited in our capability to manage it in our head, we need to externalize it, and we need to start doing that. So that's basically the second step. So the first is declare that you want to do that, and second is start understand, like do an inventory of the tools that you use, like what experience you had with formal thinking, with visualization, like who can help with that, how we can start working on that, and then just starting creating this evolving system, which hopefully very quickly will start self-improving through the what is called the learning organization, a model by Peter Senge from 1990s. Many of you are familiar. And if I connect it to what I was talking about, I think Peter Senge's framework was excellent. The only thing that it was missing is externalization and visual language to share those mental models in an organization. And I think with the tools that I described and showed, it should be clear that the learning organization approach can be very much enhanced and applied for this. And of course, going back to Engelbart, what he envisioned is that somebody should create this network improvement center and start the bootstrapping, which he tried to do, and then he was prevented from finishing it or doing it. And then his children and his students could not really grasp what the plan was. So essentially do the bootstrapping, create network improvement alliance or center, and just very quickly do this work, because all the tools and all the knowledge accumulated over the past half century is ours to use.
Thank you, Danila. Yes, a very large organization, one of my clients once described themselves as a learning organization without a memory. So yeah, they had trouble. Well, I think we should wind up now. Bernard, would you like to say a word or two?
I'm just fascinated how you are combining apparently a rich understanding which with a will to change. I think you mentioned the phrase will to power, but I think it's also a will to make an impact, and I find it very impressive, and I hope to hear and read more about the impact you're making. Thank you very much for your presentation.
Thank you.
Thank you, everybody. We reconvene, I think, on November the 5th, where Thomas Maddell is going to be our next speaker, and he will be talking about his work with AI. AI again, I'm sorry, but it is the topic of the year. So we'll be on that theme. But in December, we'll be reverting back to a little bit of child education themes. So thank you all for attending. Great to see you all, and hopefully see you back in November.
Thank you.
Bye bye now.
Bye.